Now that we have built language models that handle smoothing and zeros, we need to evaluate them. Let's recall what a language model is actually used for. It's supposed to tell us the probability of sentences and be able to trade off whether one sentence is more likely than another. So a language model should be considered good if, according to a corpus that it was built off of, or a training corpus, it assigns high probability to frequently occurring sentences. That means that sentence looks like it came from the corpus, and conversely, should assign low probabilities otherwise. For example, if I have a corpus of Shakespeare which I built a language model over, it should assign pretty low probabilities to tweets from modern day. There are two basic approaches to compare language models, and this is generally true of natural language applications in general that do classification. We have an extrinsic method as well as an intrinsic method. Extrinsic, as the name implies, requires things that are outside or extra. This means I need a downstream task to evaluate how good the language model is for doing that function. For example, using a language model to differentiate spelling and incorrect spellings, or trying to recognize text out of speech. We're going to run each of these downstream tasks with the language models and then compare the results. This is a great way to evaluate a language model because it uses the actual application or task that it's going to be used for, but it can be expensive because we need to involve people and time consuming. Another method that happens a lot is to first start with an intrinsic evaluation. As the name suggests, this means that we don't need anything extra. It's internal or intrinsic to the language model itself. We're going to take each of the language models and evaluate them on a test corpus. This requires some type of measure or metric to compare the language models against each other. We're going to see one in the next couple of sections on perplexity. Intrinsic evaluation basically has 3 steps. They mirror what you might find in a machine learning pipeline for building other types of systems, such as a classifier. In fact, we can think of a language model as a classifier, whether something belongs in the corpus or not. Training a language model requires first a corpus of text, whether it's Pride and Prejudice or tweets, or movie reviews. We then need to tune parameters of the language model if they're needed. For example, in Chris's section on smoothing, we saw K for the Laplacian coefficient and D for Nazar-Ney as trade-off. We are then going to compute our evaluation metrics. These two last steps require a different corpus, a development corpus which is separate from the training data, and a test corpus which is separate from both training and development. Because the most important thing is to train a good language model, we typically use the bulk of our data for the training corpus. And we'll save a small portion to try to fix the parameters appropriately, and then another small portion to test. The test just needs to be reliable enough to differentiate different possible language models from each other.